Thank you very much for joining our presentation today. Today we're going to talk about data science in practice, importing graphs, or rather importing events using graph databases and visualizing that to D3. Before we get started, let's just go through the agenda for a second. We're going to go through introductions, company story, the technology stack, why data science is important to us, some of the technical prerequisites for our open source project that we have at GitHub. And then we're going to actually review that project by importing some events and then presenting that using D3 technology. We're going to present that information over Flask, which is a Python micro framework. Back up a little bit, I'm too loud, sorry about that. All right, this is my background in the form of a property graph, and we'll discuss what property graphs are. But for the purpose of this, please just absorb this. It's very intuitive when you look at a property graph in terms of what's going on. My name is Ray Bernard. I am the founder of superfans.com, and this is some of my work history along with my education. I taught at Columbia, studied at NYU as well. Worked for some of the larger technology firms. Pretty intuitive, right? This is a property graph. And we'll go into what this all means in the next few minutes. Meet the team. My name is Ray Bernard. This is Jen Webb here. We have two data scientists on board, Lily and Alexei. All right, this is one of the most important members of our team right here. His name is Sai. We've actually programmed him. He's a bot, and we programmed him to use best practices from a promotional perspective. And so it's like, you know, when you hire Sai, it's like having a PR person promote your social media event tirelessly, 40 hours a week. All right, so how did I get started? I got started by doing a residency at B.B. King's. I'm actually the band leader of the Cosmic Blues Band. We're a band out of New York City, and we do blues music. B.B. King's, it's in Times Square. There are a few other locations, but this is actually a super club. Acts like Aretha Franklin, James Brown, Alicia Keys, Allman Brothers, ZZ Top. List goes on in terms of folks who've performed there. So this is what B.B. King is actually broken up into two parts. You have the main room, which seats about 1,000 people, and then you have a smaller bar called Lucille's, which seats about 120. So I was given a residency to perform blues music on a weekly basis, and so that presented a very big problem for me because I wasn't really famous. I needed to bring in a lot of people into my event and needed to do that quickly. Otherwise, I would not have a residency anymore. So here's a string of events that I've had at B.B. King's. Actually, all of these events have been sold out. The room that I had my residency has 120 capacity, and the kind of events that we did there brought in like in excess of 300 people, the ones that were sold out. So we actually had to, turn away people at the door. Here's a view. It's pretty dark, but this is the view of one of the shows in that room. As you can see, it's a pretty successful event. Here's another view of that. Here's another view. Actually, this is actually my first event there. This is Alan Merrill, who wrote the song "I Love Rock and Roll," which is a very famous song. And that's me right there. So if you find Wall, that's me in the hat right there. Just a side point. And this is another shot of us. So I use Facebook. I started off with Facebook. Why Facebook? It's the big gorilla in the room, right? So 35 million people every day look at a public Facebook event. So that's a dramatic number. So there's a lot of opportunity there, but there's also the challenge, right? You're not going to expect to put a Facebook event and have it well attended, unless you really do some active marketing, some creative thinking there. So what does Superfan do? We use unique technologies to drive attendance via social media. We do this in a very personalized way, thoughtful way, at scale. We also do deep data science analytics to discover who the superfans within our network is. We obviously save promoters in excess of 20 hours or so of social media work every week. So Superfans does grow your social network organically, reaching out to your targeted customers, fan base, based on past events. We can do that organically, and we do this. We market through email, instant messaging, and SMS from our from a delivery perspective. Now we realize that using data science gives us the ability to really hone in and market to folks that really are interested in receiving our content rather than just doing a shotgun approach, if you will, and hoping things stick. Oop. Sorry about that. Yeah. So I just wanted to show you a little bit in terms of numbers. This just represents the Cosmic 9 months of testing. So we have 3 events here. On the left, they're interested. So these are 3 events. When I first started running our system, we had 103 folks that said they were interested, 124 that went. And as you can see, there's a steady increase. And we actually, in terms of people who actually went, we experienced 173% boost. Yeah, Superfan does work. We actually had a great meetup in New York where actually we received 456 RSVPs. Actually, only about 150 folks attended. So we not only do this for music, but we can do this for corporate events as well. So from a technology perspective, this is how we build. We utilize Dockers. Dockers is a virtualization technology that makes producing our infrastructure very easy and repeatable. In terms of the cloud providers, we started using DigitalOcean, very easy to use, low cost. However, when we're looking at deploying from a scaling security perspective, Amazon's Web Services is the way to go for us. In terms of the operating systems that we use, Ubuntu Linux, along with Engine X, which is the web server. And of course, from a graph database perspective, we use Neo4j. All of this stuff is open source. From a language perspective, Python is a de facto language. JavaScript on the front end, along with jQuery, CSS, and HTML. And of course, we do our visualizations directly through D3. So we chose DigitalOcean, as I said, because it was easy to use. It had a really fast setup, great documentation, and soon nothing, so you can get quickly started. And we actually started using DigitalOcean and Neo4j in conjunction to allocate resources for our application, which actually works really, really well in that configuration. So Docker and Ubuntu is a winning, solution or combination. So why harness the power of the graph? Well, we actually, when we started building our application, we, obviously started marketing with Facebook. Facebook is built on graph technology, so as all these other companies. As a result, that gave us, a very strong interest to design something that was somewhat compatible. And we actually ended up choosing Neo4j for multiple of reasons, some of them which I'm going to go into right now. This is a really strong reference. So Neo technology actually was found to be thousands of times more efficient from a performance perspective. In terms of writing the amount of code, it's a lot more compact, so you can do 10 to 100 times more. Well, use less code and be more efficient, rather. So that was a big reason. The other reason is that you can kind of go from ideas in your head to actually deploying a graph database very easily. There's a lot of help to get started. Neo4j is the leader in the marketplace, and they have an absolutely great community. And so these are all the great reasons why I chose Neo4j. This is what a property graph is in essence. So basically, you have a node. A node could be thought in terms of a noun, it's a thing, right? And it also contains key value pairs. So along with a directional relationship, this is actually a sample of a directional graph. So it has a direction. You have a node with an arrow pointing this way. This is a relationship which also contains a key value pair, which is pointing to another node that contains a key value pair. So you can think of it if you translate it to English, nodes are essentially nouns. Key value pairs are what describes it as an adjective. The relationship does something is a verb, and what describes that is the adverb. So it's pretty straightforward. So in our use case, in our world, from an event promotion perspective, we have an RSVP user who has a key value pair of being a blues music lover and an RSVP status of going to our event dated August 25th. So it's pretty, intuitive. When you look at graph databases, you can actually express them very easily visually. And me being a visual person, I naturally gravitated towards them. So data science can help our customers predict. Why is data science important? Well, it's going to help us predict, event attendance, future returning RSVPs. It's going to help us try to identify network influencers. It's going to also help us identify various communities within our social network and ultimately discover the superfans. Okay, so this is some of the learnings that we found out from an event, predicting event attendance. So event popularity in a network is determined whether or not your friends are going to the same event. So if you have a lot of friends going to an event, more than likely you'd be somewhat interested in what's going on. From an event perspective, from a location perspective, special factors are important. So the closer the event is to where the person lives, the more likely that they would go to that event. Past events is another thing that's pretty important. If they've attended an event in the past, is obviously a good indicator of attending an event in the future, as well as advanced ticket sales, RSVPs, is another indicator. So let's step back for a second and talk a little bit about graph theory. I threw in these slides just to give us some context in terms of how graphs started. It all started here with the 7 bridges of Königsberg. Okay, that's a small medieval village. Now it's actually part of Russia. But essentially, the puzzle was this: how can one cross a bridge just once and get to all parts of the land, just crossing the bridge once and never retracing it? And so that was the riddle. So there were 7 bridges, and it turns out it's an impossible thing to do. Okay, so they've actually posed that to a great mathematician, Leonhard Euler, and he came up with a pretty interesting solution, in the sense that he was able to distill this problem and break it down to its fundamental parts. And he found that the route within the land wasn't really important at all. What was really important, is crossing over the bridges, obviously, and so he was able to create the land areas as just simple nodes, and then the bridges were represented as these vertexes. So once he distilled the problem to a graph, this was actually the first graph, he was able then to decipher that what was really important to solve this problem was whether the edges were odd or even. So in other words, this is an odd edge, right? And the amount of edges is 1. One is an odd number. This node here has 2 edges, right? So that's an even relationship. I keep jumping back and forth here, I apologize. and obviously the last node has another odd relationship. So there's two cases where this problem is solvable. One is when you have two nodes that end and that have odd relationship, or all the nodes have even number of relationships going into them. Okay, so that's the only two ways the seven bridges of Königsberg is solvable. And so this is like the first use of graphs to come up with a theory, thanks to Leonhard Euler, excuse me. So let's talk a little bit about some of the theory that's out today. So these are measurements of centrality. Measurements of centrality really gives us an indication of how important a particular node is. And it's a pretty simple thing, actually. And all it does, it's called degree centrality, and all we're doing here is just counting the amount of relationships and saying this node here has 8 relationships, whereas node A has only 5, so node G is much more, well, it's more popular than node A because of the amount of relationships. Another concept that's pretty important in terms of graph theory is something called betweenness centrality. And all this is saying is that to get to the shortest path, it gives, betweenness centrality is a score, right, that measures how many times you have to go from one node to get to another node, and it gives you a score. So for example, node H has the highest betweenness centrality because it acts as a broker. So all these nodes out here have to kind of go through H to get to I and J. And so from a graph theory perspective, finding out who these brokers and these middlemen, if you will, are is important to understanding who the influencers are or the brokers are in your network. Another thing that's pretty important to us is this, what we call clicks. And basically this is a situation in your graph where all the nodes know each other. And it's pretty important when you discover these because it's a great way to spread, the event information. Information is spread much more quickly when you're working and you're finding these clicks when everyone knows each other. Okay, so let's take a look at another measure of importance, and that's the eigenvector centrality. I know some of you guys have heard of this, but essentially this looks at importance, right? But it also looks at the relative connections between the child node, and also calculates the parent nodes, and it comes up, and the score comes up. You can think of this as Google's PageRank. This is what they use to calculate PageRank, but it's actually called eigenvector centrality. Okay, the other thing that so here's another interesting graph theory concept, and this is pretty intuitive, actually. Basically, it says if you have two strong relationships, you can actually predict that a third relationship will happen. And if you want to do predictive analytics and predict if these relationships would occur, you can count the amount of triangles you have in your graph, and you can say, hey, those triangles more than likely will induce another relationship. Now, for example, if you have two friends, Jack and Jill, right, and they're really good friends of yours, and you have very strong relationships with them, eventually they will meet. Okay, they will meet, through a party, through an event, through a wedding, funeral, etc. They will meet somehow, and this happens to, be transpire in nature, and so you can kind of use that to, do predictions. The other thing, another concept is local bridges. Local bridges is important. Inside of triad closures, you can actually discover a local bridge and find a different network. And so, like, for example, if you're looking for new employment, more than likely you would need to actually look outside of your network, simply because within your network, all the same people are competing with the same resources. More than likely, you don't hang around with your bosses. They hang around in their own social circles. So, a local bridge is necessary to do that. You can do all this very easily. somewhat easily through a Neo4j. Neo4j provides graph algorithm plugins. Ever since 3.2, you can actually use centralities to do page rank between a centrality, which I spoke about, community detection. You can figure out, where those triangles are and how clustered they would be. The other thing that's pretty cool is pathfinding. So you can actually look at finding where those shortest paths are. Pathfinding applications are used. Google Maps use, pathfinding. Here's a link to describe these algorithms in a much more detailed way. So we provide you that. All right, so let's start doing some coding. We're going to look at using Facebook to get some real live events and port that into Neo4j for data visualization. Whoop, hate that. So some prerequisites before you get started. You have to download Neo4j or use, there's a sandbox that's freely available in the cloud that you can use. You're going to download our application to your laptop. You're going to configure and connect the code to the Neo4j instance because that's going to have a new IP address, so you got to connect that manually. And then you're going to go to developers.facebook.com and create yourself a web app. And then from there, you're going to follow the steps on GitHub for detailed instructions. But we're going to take you through the workflow ourselves, but you can follow along at home. From a technical prerequisites perspective, we're going to be running our application on Ubuntu 16.04. We're going to be using Python 3.x, Flask, and Neo4j 3.x. As I mentioned before, we've created some tools to get you started. We include a module to import the events. We also include a module to help convert the data from Neo4j to D3 for visualization, and we'll show you how that works. This is all open source. It's freely available and it's licensed under the MIT licensing scheme. So the first thing you want to do when you get started and you have the operating system installed and you have and you're ready to go, you're going to actually import or rather install the Neo4j driver, and it's pretty easy. You're going to do a pip install driver. The next thing you're going to do, and this is basically connect the driver, okay, with the class graph databases and basic authentication. We're just going to go through anatomy of how to connect to Neo4j. So you're going to need to import the driver. This is what this is up here. You're going to need to put in, the user name, the IP address, the password. Okay, this is the function right here, right? And what this is going to do is going to create the user. All right, simple is going to create one node, and this right here, what you're looking at, that's Cypher. Cypher is the declarative language that Neo4j uses. And what this says, it says merge. If it doesn't exist, create this. And what we're going to do is simply connect with the Neo4j driver and then point it to where it lives. And then we're going to actually feed the driver the parameters that it needs to create the user object. And then this part here basically just runs this, and what it's going to look like once I go through all of this, it's going to basically create one user with these key value pairs. Pretty easy. All right, let's pull in a Facebook event. So you're going to set up your application on Facebook. All right, you're going to go to the developers, facebook.com, and you're going to actually create a user token. Okay, we do this automatically for you, by the way, in the application, but I think it's important that you guys know how to configure the application itself and know how to run parts of it manually. So the first thing you're going to do is you're going to grab a token once you've created the Facebook application. It's this long string that gives you the authentication to use the Graph API. The next thing you're going to do is you're going to grab this number here, and that's your Facebook event ID. So with those two pieces of information, you're going to actually open up this file, which is called run get Facebook event class. That file actually pulls the Facebook event. And so what you're going to do to run it locally is you're just going to put in the event ID that you took out from the event, the Facebook event, and then you're going to put in the token here. And then all you're going to need to do is just type in Python 3 space run get Facebook event class, and it's going to pull in the Facebook event itself. And this is how it does it. This is actually that file opened up. What we're going to be using is the actual request object from Python to pull in the, to connect to the Graph API. This is how you connect to the Graph API right here. All right, and what we're going to do is we're going to feed it an event ID, and that's going to actually pull the event description along with the start time of the event, and then what's going to happen, it's going to pull that into the driver, and it's going to populate the actual Facebook event. And this is the Cypher query right here that will actually help you do all of this right there. Okay. All right, so let's get ready for visualization. I hate when that happens. Okay, so the first thing that we need to do to prepare this data, now that's in Neo4j for visualization, is actually transform it and make it compatible so that it works with D3. And there's a few things that happens here. So the way it works is this. It creates two arrays. One is array of nodes, and the other one is array of edges. And the way the nodes are connected to the edges is you have a source and target, right? So you'll take one node, and one node will be a source, and another node will be a target. So in other words, this node is directional and is related to that node from a target perspective. Okay, so this is the actual code that we use to convert the data from Neo4j to D3. This happens automatically. You don't need to do this manually, but we're just showing you what happens. So I'm creating nodes here. I'm creating edges. And what I'm doing is I'm actually pulling the event information and creating actually a JSON object that we'll use in our web application to present the D3 visualization. So all right, now we're ready for D3. Why don't you get us ready, Jen?
D3, what is D3? It's a data visualization language in JavaScript for producing interactive data visualizations in web browsers. It makes use of SVG, HTML, and CSS. In contrast to many other libraries, D3.js allows greater control over the visual results, so it's very customizable. And it can be used to produce many different kinds of interactive charts, graphs and diagrams, heat maps, scatter plots, bar and line graphs, pie charts, and so much more. And here's some examples. Bar chart, bubble chart, donuts. But we're going to look today at the force layout, as this is a preferred representation of non-relational graph data, such as that from social media. What is a force layout? It's also called a force-directed graph drawing, a class of graph layout algorithms that calculate the positions of each node by simulating an attractive force between each pair of linked nodes, as well as a repulsive force between the nodes. All right, and so we know there is a lot of code on these slides that may be hard to see. We are planning to provide the slide deck at the end of the presentation. And also for the application itself, it is on GitHub, where we'll provide a link. There's a long and detailed README, and of course, we're going to be available anytime by email, so you can ask us the questions. All right, so visualization starts with an SVG element in the HTML that we bind the D3 code to using D3 select SVG. So first we define the dimensions of the visualization using jQuery to get the current width and the height of the screen when the page loads. That makes it so it always fills the screen no matter what kind of device you're loading it on. And the height and width are set with chained methods, the attributes. So here's, luckily I loaded it already before we lost the internet. So this is what it looks like. And I preloaded this graph with some blues events in the San Francisco and San Jose area. And you can see they're all pretty interconnected. If we inspect, there's the SVG element, and there's the height and width. All right, so now we can create a force layout object and define its properties. Those include the arrays of nodes and links. So broadly speaking, there's 4 steps to setting up a force simulation. There's creating the array of objects, which we did with Neo4j in Python, as Ray showed. And then there's the call force simulation, passing in the array of objects. Add 1 or more force functions from D3, such as force many body, force center, force collide. And then set up a callback function to update the elements after each tick. Yay, looks like we have some internet. That is great. All right, so moving on to the slide. And next, we add the nodes and links to the visualization, and bubbles and sticks, as we like to call it. So this is just where we have, we start with the links because SVG doesn't have the Z index or Z index. So by adding the nodes after the links, we make sure that the nodes are going to appear on top of the links. And links are just the sticks, and nodes are just the bubbles. So D3 nodes and edges can have styles and functions attached based on data properties, but also by attaching groups or values. In this case, we attached a value to our links so that we can use functions to change the color, distance, and line thickness. So here, we are using the value to look at the relationship type. These are guests, and their relationship to a Facebook event is going to be, this is an event, for example. And then if these stop bouncing around, we can see the gray ones are no reply, and the orange ones are interested. This one doesn't want to stop moving for me. And then there's some green ones in there as well for going. And that just gives us an easy way to say in our visualization the relationship types. You stay still. There we go. And we also add some hover and click functions to so we know exactly what we're looking at in this little information bubble here. So what I've done is I've printed it to the console, the D object, which has the data properties that are passed through D3. So in this case, this is a Facebook guest, and if you look here, it's a node, and these are the properties you can get from it. And then there's a relationship would be here, an edge. And the RSVP is not replied, and it has the source and target information as well, which are like sub-objects. All right, so we assign the group to differentiate the nodes. So in our visualization, we have just yellow and big for events and blue and small for guests. D3 makes it possible to append SVG elements and properties to achieve the desired effects. So I'll show some examples later, but people have done many different things, like including images of Marvel comic characters, and it's really cool what you can do. We've kept it quite simple here, so you can add to it and build on it. And there's different ways of controlling the animation and interactivity using functions based on drag events. For example, drag ended. I commented this out in the code. Where did I put that? But yeah, this is, if you wanted to uncomment that, it wouldn't lock the nodes when you click on them, but keep them moving around as they do. But I prefer myself to have them stay where I put them when I click on them. And then we also attach mouse events to the nodes and edges to add interactivity. So this is where I'm pulling in the Facebook information, and you have a link to the actual event. And also for the guest nodes, you have their profile links. So if you want to be a creeper, you could do that, but we won't for this. But sometimes the picture doesn't work because it's just a Facebook thing where they have an old image cached, and the link for the new one isn't working for some reason. But then, all right, yeah, so we just did simple jQuery functions to output the information from the D object down here into here. So time for a fun demo. All right, so I don't know if everybody saw my comment on the meetup groups, but we made some events on Facebook that were based on color, and we asked people who wanted to participate to join these events. So a few people did. So, oh yeah, I forgot. This is the actual graph in the Neo4j database. So the same thing, and the D3 visualization allows you to view it on the front end, so you don't have to have the database admin credentials to see it. But okay, so now we're going to see if we're going to delete this data and import our Facebook events. So we'll go with that. Oops. Did we lose our internet again? Is it right? I did it right, right?
Yeah, you did it right.
Yeah, it must be the internet.
Connection. Try refreshing and logging in and out of the database. Seems like you have the connection. Just move that. It's not going to delete. Try it again.
Okay, there. All right, so we just had to refresh the database, and then it worked. So yeah, and we'll refresh this as well, which it may, because we lost the connection. Oh, okay, it didn't. I thought it would crap out because we lost the database connection, but it didn't. Yay. So this is, now it's blank, and we're going to import these events. So all you do is you copy and paste the event URL and press import. And It'll depend on how big your event is, how many guests is, but it's reaching out through the API and pulling this data into Neo4j, and then it's going to output it into this visualization.
Do you run into any sort of
There it
limits
is.
on what you can pull on Facebook?
Yeah, there is a limitation on
Yeah.
Facebook.
This is publicly available data, basically. So
we
if
have a
private
question.
events,
Jen, we have a question.
I'm answering that.
Okay, thank you.
But yeah, the question was, are there limitations on what kind of data we can import from Facebook? And yes, there is. This is publicly available data that we can get through the Graph API. So there's a lot of detailed documentation in the Facebook Graph API that explains to you. All right, so there's our second event, Team Blue, and now for
My
our
question was actually the amount.
The amount, yeah.
Oh, okay.
Limited.
It does slow down
Yeah,
with
there
performance.
is a limit. I think it's
No.
like 5,000 objects. How many objects can we pull? Oh, was it
Yeah,
2,000?
Facebook does limit it to something like
Was it
5,000
5
at
or
a time.
2,000? I forget.
But we have sometimes run into other limitations
Yeah.
where it was even lower for really large events that have like 2,000 plus guests. That can be an issue sometimes.
Yeah. But you still can get the data. You just have to get it in chunks.
You throttle it.
Yeah. You throttle it and you get it in chunks.
Yeah, okay, so here's our 3 Facebook events that we asked people from this meetup to join. So there's Team Yellow right here, and there's Team Blue over here, and there's Team Red right here. So right in a way you can see there's some common guests and some only joined one. And so just for fun, I'm going to select somebody at random, and that person who's here can come up and get a prize. But you have to be there. You have to be here. So the first person is David Berkowitz. Come on up.
Come on.
So this is a bag of Neo4j merch that they were kind enough to give to us, and you can pick the item that you want.
You have pretty good items, so you have. No, you can. No, you can look.
Yeah, take what you want.
What do you recommend?
I like the keys. I like the keys. They're great. Yeah. So USB key.
And one more thing.
Yeah. Before you go,
You get to pick someone else.
Now you get to pick someone.
Yeah, so I'll just center that for you. Yeah.
So we have a touch screen, and who's gonna come
The
up?
guy who didn't follow instructions.
And we're picking
Jerry Chan,
Jerry. Yeah, come on up.
come on up.
All right. Thank you so much. Thank you. Thank you very much. Yep. All right. So you pick any one you want. There's keys, USB keys, this, that, whatever you want. Yeah. Okay. Great.
And yeah,
That's
you
it.
can
So
come
now you
pick
have to
someone else.
There you go.
Pick the one you got.
And one of the blue nodes.
One of the blue nodes. So just pick a blue node.
Oh, that's me. I already have enough. I already have the shirt. I'm set. Yeah, one more.
All right.
Xingran Zhang,
Come on.
come on up.
All right. Lucky. All right. So you get to pick a prize.
We got lots of stuff, so let's pick
Yeah.
one more person.
Yeah. So okay, you can pick. Yeah, absolutely. Pick whatever you want.
There's fidget spinners in there.
Fidgets, whatever you like. Go for it, and then now you have to do the task of picking the next one.
Yeah. Just click on any of the blue nodes.
To the blue node. All right.
Ashutosh. Is Ashutosh in the building?
No?
I'm sorry if I'm pronouncing that badly.
It's okay. Pick
Yeah,
another
one
person.
more.
One more. Let's see.
Mayuri?
No.
No.
No. Okay.
Victor? All right.
All right.
Yeah,
Victor.
that'll be the last.
All right. Thank you so much.
Yeah.
And, pick up the prize. Pick up that here. Pick If you're on your keys, balls, whatever. Yeah, absolutely. Sure.
Yeah.
Okay, thanks. All right.
All right.
All right. Well, that was it.
All right, so that was fun. And so here's what I was saying about different things you can do with D3 that we like. So here's the Marvel characters one. And then there's the Twitter emojis. Basically, if it's got fun pictures on it, I like it. And also the 3D force layout. Oh, did we lose the internet again? Well, as I say, we're going to be providing the slides, and the links are in there, so you can look for yourself. But there's so many possibilities of what you can do with D3, so we've kind of helped you with the pipeline of getting the data from Facebook into Python, into Neo4j, and then out through D3. And then you could take that and make any kind of visualization you want out of it, really. Oh, now my PowerPoint is frozen. That's great. But I think that's the end anyway.
Yeah, we're just at the tail end, but we can switch to this.
We can switch back to yours.
Yeah.
Sorry, you can't click on links. Yeah, clearly. Oh, it's back. Okay. So in closing, we imported a Facebook event into Neo4j via the Facebook Graph API, reviewed Superfans tools to help you import the event and produce JSON data for visualization, reviewed a Superfans Flask app, which produces the visualization. Next steps, join Superfans by going online and submitting an application. We are looking for some developers, data scientists, Python backend, front-end developers, and of course, if you're an investor, let's talk. But please feel free to contact us about that, or if you just have any questions or just want to talk about data science and D3. And
Absolutely. So,
yeah, oh, there's the slide. It was in the wrong order.
you want to show them the links? I think we have.
Okay, yeah, we have some helpful learning material, some guides on Python, Flask, Neo4j, the guide to the graph algorithms, and more links on D3. And NetworkX.
Can you put your PowerPoint on my USB key?
We could.
Yeah.
That's our GitHub.
Yeah, we could, yeah.
And thank you so much for coming out, and we got some time for questions.
So, questions. We have a question over here. Let me just come right over here and with the microphone. How's that so everyone can hear it? What's your question?
You showed how you color-coded the edges.
Yeah.
Can you group similar edges with a similar color? So all the greens would kind of cluster together and all the reds and yellows and or whatever other colors you were using?
Yeah, there are ways of doing that in D3. I wish I could remember what they are right now.
Yeah.
But it is
absolutely possible.
Probably the
Yeah.
collision and charge.
Yep.
In
Next
the
question.
simulation.
Yep. Okay, we have a question over here. We have a few questions.
Yeah, my question was in terms of displaying real-time visualizations. Do you have any plan on doing that, and how do you attempt to solve that problem? Or
real-time visualization. When you say real-time visualization, what exactly do you mean by real-time?
for example, displaying how people are interacting with events, or how displaying the graph in real space.
Yeah, I mean, this is pretty much displaying the graph almost in near real time. Well, as real time as you can get the event to kind of download and get processed.
It would have to be something that constantly pulls updates from the Facebook API.
Right, you're right. But you could do that. You can pull the API, pull that in, and then visualize what you see. I mean, what comes down out of that. So it's possible for sure. Yep. Next question. Yes.
So I imagine that you will be supplementing or competing with Facebook's own advertising. So what is your main advantage over or difference from them?
You want me to answer that?
Yeah, it's your turn to answer question.
That's actually somewhat true. Main difference is that we're a lot more effective in terms of how we get our responses. Facebook will advertise on your timeline and then post that up. We actually are very much direct in terms of how we communicate with our target group from a messaging perspective.
Yeah, also Facebook very much, they want to keep you on the site for as long as possible, whereas we're kind of trying to do the opposite and get you to get what you need done without having to linger on the site to look at ads and all that.
Yeah, that's very true. So the type of activity that we can do with our application, you could never do that with Facebook. Just because of the nature of what Facebook is. They want to keep you addicted and attached there on the screen. And if you have to kind of invite people, you have to do it painfully one at a time. We do it at scale, so it's a lot different. Yeah. Next question? Okay, in the back here.
I just saw that D3 visual. The one problem that normally we face with the force layout is every time we reload the page, the position of nodes and edges won't be the same as previous. Do you guys, or did you spend any time in having a predefined location of nodes and edges with respect to D3?
I have not told the nodes where to go, but I have found that usually when you reload the page, they're pretty consistently showing up in the same place. Kind of like here's one, and then if I reload it again, it'll probably look pretty much the same.
But that's with the small, and suppose if you're having some 500 nodes and edges kind of thing, I don't think it will be the same case.
There are functions available in D3 to force the placement. You can also make it so that they're still and they're not bouncing around like this. And
okay.
There are functions that you can use to determine the coordinates of the node as soon as upon drawing the visualization.
Okay.
With the tick functions.
That means you mean that we should save those coordinates in a database or something like that?
That's a good question. No, it would be more like you would use some math calculations to calculate whereabouts on the screen you want them to go. It would be more relative.
Okay, and one more question before I give it. So why did you guys go with D3 rather than going with any other libraries like Sigma.js or something? Because D3 has the problem of SVJ. I mean, whenever you can't load more than 500 or 1,000 nodes in a page, and because you're mostly HTML page, and D3 always returns in SVGs, what made you to select D3 and not go with any other libraries?
Well, we've mostly had experience working with D3. We haven't really explored Sigma that much, other than just a little bit of cursory overview. But yeah, we're definitely interested in investigating some other types of visualizations as well.
Okay, good. Thank you.
Thank you so much. Any other questions? Okay, we have a question back here.
Thank you. Hi, I have a quick question.
Hi.
So I'm not too sure, but I think I've seen D3. Somebody used it from Python or within Python. Is there something like that, or is there a limitation if there is such a thing?
I think D3 is front end, so it would be pretty hard to go direct. You could send basically we'd have to send the JSON data to the D3 script, which is JavaScript, which would have to be rendered on the front end in a HTML.
Sorry about that. Any other questions? All right. Well, thank you very, very much for attending our... oh, we have one more question. I'm so sorry. Sorry.
Thank you. So I think when you started presentation, you were talking about acquiring larger, potential people who would go to your events.
Yeah.
And that I feel kind of separate from the D3 visualizations, and I'm trying to understand what was the real connection, because it seems like for picking up who to advertise, you use Python and looks like centrality and so on and so on.
Absolutely,
right?
But yes, absolutely. That's a very good question. Okay, so we use centrality to determine who's important, but D3. This is a portion of our application that we're going to actually present, and this is only.
This is an open source tool that we're offering. It's not the actual the main application.
It's not a main application. This is only a very sliver of something of a page that we do. I mean, we just kind of wanted to expose that and teach how we go about creating this visualization. Yeah, absolutely. All right. Any other questions? One more question before we wrap it up. Well, thank you very much for coming, and thank you for your time. Please email us, stay in touch with us. Thank you so much. Have a wonderful night.
Thank you, everyone.
Thank you. It's been a pleasure. Thank you, H2O AI, for this. Appreciate that.